Concept and principle of pre-stressing. What is pre-stressing? Pre-stressing is the mechanism or process, usually via steel wire or string, for concrete element to be compressed. Pre-stressing has two types of process. First is post-tensioning, which is the structure stressed when complete. Second is pre-tensioning, which is the precast element being pre-stressed during construction. When the element is loaded, pre-stressing compensates for the tensile stress added. The concrete does usually stay in compression. Principle of pre-stressing. Pre-stressing is a method in which compression force is applied to the reinforced concrete section. Pre-stressing will reduce the tensile stress until below the cracking stress, so the concrete will not crack. The concrete has two compressive forces, which is internal pre-stressing force and external forces. It must be counteracting with each other. Concept of pre-stressing. The concept of pre-stressing has been done before. Example of pre-stressing concept is how it works on the wooden barrel. The tightening of the metal band around the wooden staff make they under tensile pressure, which create compressive pre-stress between the wooden staff. The compressive pre-stress help the wooden staff to allow to cater or resist the tension of the internal liquid pressure. There are three basic concepts of pre-stressing. The first one is pre-stressing to transform concrete into elastic material. The figure shows that stress distribution across a centrically pre-stressed concrete section. The concentric tendon on the beam can produce pre-compression, which can prevent or delay the cracking. By pre-compression, the concrete can be transformed into elastic. Secondly is pre-stressing for combination of high-strength steel with concrete. High-tensile steel is embedded in the concrete. It can make the concrete cracks. The figure shows that in the simply reinforced concrete, high-tensile steel make the beams cracks and excessive the deflection, while in pre-stressed concrete, there's no cracks and only have small deflection. Pre-stretching and anchoring the steel can produce compressive stresses and strain in the concrete and tensile stresses and strain in the steel. Lastly is pre-stressing to achieve load balancing. When using the load balancing, pre-stressing tendon was designed for a pre-stressing force to balance all the portion of the dead load so that the members such as slab and beam will not subjected to flexural stresses under a given load condition.
Types of pre-stressed concrete. There is two types of pre-stressed concrete, which is pre-tension concrete and post-tension concrete. As for pre-tension concrete, the wires or tendons are tensioned before the concrete is poured. Therefore, the tendon is protected from corrosion and tensions are transferred directly to concrete. As for post-tension concrete, concrete is poured before tendons are tensioned, and it is widely used in slab construction because it is easier to build.
S&P Post-Tension Company Limited is a company operating business about designing, estimating price, and producing and installing post-tension, as well as giving advices about technical matters by proficient and highly experienced engineers and teams to respond satisfaction of customers with quality and punctuality. Step 1. Installing slab formwork. Step 2. Installing side formwork. Step 3. Placing lower reinforcement. Step 4. Installing anti-bursting reinforcement. Step 5. Placing lower reinforcement in column. Step 6. Installing punching shear reinforcement. Step 7. Determining position and placement of bar shear by profile height. Step 8. Placing tendon and tied with bar shear. Step 9. Installing anchorage and grout vent. Step 10. Placing top reinforcement and extra reinforcement. Step 11. Pouring concrete. Step 12. Removing side formwork. Step 13. Removing former. Step 14. Inserting block and jaws. Step 15. Stressing and measuring elongation. Step 16. Cutting strand end. Step 17. Filling socket with mortar. Step 18. Bleeding air for cleaning. Step 19. Grouting. Step 20. Removing scaffolds and back prop from excessive weight the floor can support. It starts from step 1 until the procedures are completed.
Now I'm going to discuss about why precast concrete is preferred compared to conventional in situ construction method. For simple understanding, here is the statistics taken from the journal titled Survey of Precast Concrete Method and Cast in situ Concrete Method by Virendra Sham VS. As you can see from the bar chart here, precast has contributed in 20% less concrete, 30% less steel, 50% less manpower, and 50% less wastage compared to cast in situ. And from the line chart here, the number of floors completed by precast construction is more compared than the cast in situ construction in short amount of time. Here is only the summary from the journal. For better understanding, I will make a comparison between precast construction and cast in situ construction in 5 different factors taken from the journal, which are material requirement, labor efficiency, quality control, weather, and time of construction. For the first factor, material requirement. Precast concrete method require less material quantity. It requires less concrete cement and steel as it is factory-made advanced mix designs and better vibrations are used. No formwork is required on site for precast concrete method. As no need for storage of materials and formwork, precast concrete method is very useful in small size construction site with less storage space. As quantity of materials is less, wastage is also less in precast concrete method. It is about 50% less than in cast in situ method. The next factor is labor efficiency. Precast is much more labor efficient because work is done in a factory. The effort is maximized through the use of tools and machinery that simply isn't available on the job site. Therefore, with site casting, work that might be done with machines has to be instead performed by hand. This is much more labor intensive, thus increasing labor costs and making the process more costly. Additionally, because machines aren't involved, the labor needed for on-site casting needs to be skilled rather than unskilled. Thus, not only are more labor hours required, but those labor hours are more costly. The third factor is quality control. Since precast concrete is mixed, poured and cured in a factory, ideal conditions and exacting measurements can be maintained throughout the process. Water-cement ratio can be properly adopted in precast concrete than in cast in situ concrete, which can lead to better quality control. In cast in situ method, concrete is prepared on the site, which can be affected by humidity and temperature of the day of doing casting. For the weather factor, an unexpected rainstorm can cause construction work to stop if it occurs when doing site casting. Thankfully, this simply isn't a problem when it comes to precast solution, since they were made in a factory. Lastly, precast concrete method require less time for on-site construction as compared to cast in situ concrete method, because as prepared materials are transported to site and can be directly lifted and placed on the desired positions. Precast element can be delivered just in time for fast erection, reducing unnecessary handling and equipment use. Fast construction on site also means fewer disturbances for surrounding properties. Cast in situ method of concreting requires lots of time because concrete requires minimum 28 days to achieve 99% strength of its total strength. Thus, after creating one element, only after 7 days a new element can be created, which is dependent on previous one, because concrete achieves 65% strength of its total strength in 7 days. Here is the summary of 5 factors discussed, which were material requirement, labor on site, quality control, weather effect, and time saving. As you can see from here, precast concrete have more advantage and more preferable than the cast in situ concrete method. This is a video of construction of precast villa superstructure. You can see how easy and fast the precast construction was made, as they can already build 3-floor building in just a day. In conclusion, maximum number of homes with greater quality within minimum time can be provided by using precast concrete method than using cast in situ method of concreting.
How much cement is in precast concrete? Usually it contains 10 to 12% cement by volume. The cement chemically reacts with water to bind all the ingredients together. According to DOE, or Department of Energy, cement production usually gives out 1 to 2% of CO2 emissions through burning of fossil fuels. Oh my gosh, that leads to carbon emissions. What is actually being done with CO2 emissions during the manufacturing of cement? Well, since 1975, the cement industry has reduced CO2 emissions by 30%. Oh my gosh! Today, cement production accounts for less than 1.5%. Such a big achievement for carbon dioxide emissions reduction, well below other sources such as electric generation plants for heating and cooling the homes and buildings we live in. What can happen when you start reusing the products, which contributes to reduction of waste materials? By reusing products and containers and repairing what can be used, precast concrete panels can be reused when buildings are expanded or dismantled. Concrete pieces from demolished structures can be reused to protect shorelines. You know, the one on the sea. Wood and fiberglass formwork used to make precast concrete products is generally reused 40 or more times. Yes. Concrete and steel have practically unlimited service life. That means they're godlike. Excuse me. By recycling as much as possible, industrial waste such as fly ash, you know, the one that flies like an ash, slag and silica fume can be used as partial replacement for cement. Wood and steel forms are recycled when they become worn or obsolete. Amazing.
Precast concrete construction use less toxic material. According to article titled Precast Concrete Manufacturing and the Environment, new form oils that contain a mix of biodegradable oil are available and precasters are starting to use this non-toxic oil to produce precast concrete. There are also biodegradable non-toxic materials that can replace muriatic acid to remove concrete and rust from in precast concrete construction. These less toxic materials are environmental friendly and automatically will reduce carbon dioxide emission and global warming. Precast concrete construction is energy efficient. From an article titled Sustainable Precast Concrete, energy efficiency is a part of the design of precast structure. The thermal mass of precast concrete can absorb and release heat slowly, shifting air conditioning and heating loads to allow smaller, more efficient heating, ventilating, and air conditioning system. Insulation can be incorporated in architectural exterior wall panel to increase thermal efficiency and provide continuous insulation in wall. As the energy release is efficient, carbon dioxide and global warming issue can be reduced. Precast concrete construction reduce construction time. According to article titled Precast Concrete Manufacturing and the Environment,
The process of pouring on-site creates unexpected delay that result in wasted concrete when the ready-mix delivery has not been properly sequenced. By using precast concrete construction, this issue can be managed. Thus, construction time can be reduced. As the process of construction will emit carbon dioxide gas, the time reduced will also reduce carbon dioxide gas emitted and control global warming issue. Precast concrete construction contribute to green building practice. According to an article titled Sustainable Precast Concrete, precast concrete mass can shift heating and cooling load to reduce mechanical system requirement. Because it is factory made, precast concrete reduces construction waste both in the factory and on the job site and does not add to construction indoor air quality concern. The green building practice will release more oxygen, thus carbon dioxide emission and global warming issue will be reduced. Precast concrete construction reduces the use of material such as cement, stone, sand, steel, timber, formwork and others. From a journal titled Social Environmental Benefit of Precast Concrete Technology, reduction of material can reduce the energy from manufacturing and processing of this material. In the manufacture of 1 ton of cement, approximately 1 ton of carbon dioxide is emitted into the atmosphere. Thus, by reducing the quantity of cement used, amount of carbon dioxide that is emitted into the atmosphere also reduces. As the amount of carbon dioxide that is emitted into the atmosphere reduces, the global warming issue automatically can be reduced.